So welcome everybody. So this is the second talk in our principal investigator series that we are organizing here at the University of Trento. We had in the last month an initial talk by Marian Verest from the Catholic University of Louvain, and it was a very interesting talk. And today we will listen to another success story by Laura Kovács that I'll briefly introduce. So Laura is a full professor in computer science at the Technical University of Vienna, and she's leading the automated programs reasoning group of the formal methods and system engineering division of the Technical University of Vienna. So her research is focusing on design and development of theories, technologies, and tools for program analysis based on theorem proving and automated reasoning. And during his career, she was awarded first of an ERC starting grant in 2014. Then this was followed by another ERC grant for a proof of concept in 2018. And she recently was awarded of the very prestigious ERC Consolidator grant on this topic. And today she will present a brief introduction of this last project, and then she will tell us about her experience, her feeling in getting this kind of grants. So Laura, please, you have you can go on.
Thank you very much. Thanks for inviting. And so I'm very happy to present my story, to some extent success, but anyhow, my story as a principal investigator on basic research. And I will actually start by really mainly focus on the work that is planned on my new ERC Consolidated grant that it's set to start in July 21, so this year. And you know, the name of the grant is called ARTIST, and it's really for automated reasoning with theories and induction for software technologies. So how I will structure my presentation, I will first tell you about, you know, what can you do or what can you expect in ARTIST, and you are welcome to join the ARTIST efforts. And then I will go a bit broader, in a sense, sharing my personal experience as a principal investigator. What was my path to lead to being a full professor even in computer science and a principal investigator of 3 ERC grants. So let's just do the first part, which is a bit more technical in content. And I'm you know, depending on times and questions, I can also skip some of the technical contents, because I would mainly focus, given the focus of this seminar, I would be mainly interested to share my experience as a grant acquisition experience. But let's just get, so what is ARTIST about? And now I would, of course, like a lot of interaction, which is not that possible in a virtual environment. So, you know, if I were now ask you whether have you made a software update in the past 6 months, I would actually bet with quite a high probability that you would say a yes. But now if I start continuing this questioning and ask you, okay, but do you believe actually that your software update was sufficient to ensure that your software is reliable, it's correct, or for example, no further updates would be needed, then I would actually assume that most likely with the highest probability, your answer would be a no. And this is one of the famous screens that you are used to. Okay, there is an error, software error occurred while checking for a software update. So the software could not be updated, for instance. So this kind of yes and no paradigms reflects the kind of like the daily contradiction exploited by our software-driven society. We use software products, but we don't really fully trust them, yet we are still using them, right? So the question is, why is it so hard to get software error-free? And it's a huge question, which I'm trying to address with my ARTIST project. And I just to give you a kind of flavor why I think that getting software error-free is so difficult, despite all the theoretical results that show that it's actually impossible. So let me give my favorite metaphor. So if you just take a medium-sized computer, let's say, which has about 10 megabyte cache, which would correspond to 10 to the 20 million states, approximately. And states, you know, is the smallest bit in your computer, the smallest atom in your computer. So it's a huge number, which means if you want to get if you really want to understand all the functionalities that your computer can have, you should really understand all the states in this big zoo of numbers. So it's a huge number, I would say. And here's my favorite metaphor, that basically it's known that our universe consists about 10 to the 80 atoms. Now, of course, the atoms in the universe are slightly bigger than the states in our computer. Yet this analogy I'm trying to express that 10 to 80 is already a huge amount of number. And there has been decades of research in our society to understand the universe, and we are far away from that. So it's really hard to expect that we can actually develop methods that will be able to understand all the 10 to 20 million states of our computer systems. So the situation is really not great. It's known already in 2002, there was this famous report of the National Institute of Standards and Technology that shows that basically 80% of software development costs are spent on identifying and correcting errors. And that time it was about $60 billion. So it's a huge number, but it's back already like more than 15 years now. And the situation is not improving, on the contrary. So more recent studies show that in 2016, there was 80% of software errors were still spent, or even more, on identifying and correcting errors. And the value of that amount could be materialized in $1.1 trillion US. And this is not just in the US, it's in Europe. It's actually a worldwide situation. Software errors become more and more costly. So one remedy to try to give a solution on reducing the cost of software errors is to try to use automated reasoning, which is one of the earliest areas in AI in software development. And actually automated reasoning is now becoming nowadays the backbone of formal software development. It's routinely used by companies such as Amazon Web Services, Microsoft, Certora, and these are basically 3 companies that I'm collaborating with. So far, this automated reasoning within software development is mainly based on so-called SMT, so satisfiability modulo theory solvers, which are very efficient when it comes to theory reasoning, but they are not that great when it comes to quantified reasoning. So they kind of trade automation for expressiveness, and there have been huge successes for SMT-based verification, yet software errors occur. So what I'm trying to contribute with my ARTIST project is to try to provide an alternative for bringing automated reasoning in software development by complementing SMT-based approaches, and do so by using first the theory proving into it. And you know, the general goal of ARTIST would be complementing other efforts in the area. Well, whether it's going to be 2020 or it's going to be 2030 or 2040, I don't know. But the overall vision is to try to make that we want to make the existence of software errors a rarity, together with other efforts. So just to get, okay, what kind of software technologies or what kind of problems we are addressing. So here's a snapshot actually of a partial code of our own software that we are developing for automating reasoning about other softwares. It's called a Vampire Theory Improver. It's about 250,000 lines of C++ code, and it's a medium-sized software. Out there are even huger softwares. So now, what kind of challenges I'm trying to address in my research? But here's an example. Assume in this code, there is a, just for very, very simplistic piece of code, which is basically manipulating an array A, capital array A. And depending on the array positions, I'm creating 2 portions of that array copied into B and C. So basically all positive elements from A, which A can represent your memory, for instance. The positive elements are copied into B, and the negative elements are copied into C. And the question, what kind of requirements this piece of code should have. And for instance, in my group, we are trying to address this question, basically coming up or automating the synthesis of program properties called invariant that, for instance, can express this property that, every element in array B, that's what I'm quantifying as a universal quantification, every element in the array B, it's a positive element and it's coming from an array element from A. You don't know actually which one because that you cannot express in first order logic, but you know there exists an element in A such that it results into an element B. So this kind of properties shows that this is actually where SMT-based reasoning would be insufficient, because here you need theory-specific reasoning. So you need arrays, you need addition, you need inequalities, but you also need to have a first-order quantification, even more with alternations of quantifiers. Now, another challenge that I'm also addressing in my group and trying to tackle is that, so look, in this particular piece of code, there is an uninterpreted function h. And just assume, for simplicity, or just to show the mathematical aspect of my project, is assume that this piece of code is implementing this numeric program. The names are quite intuitive. It's basically implementing Fibonacci numbers. And now again, the question is, what kind of requirements this program should satisfy in order to ensure that it's correct? So now, while we all know what Fibonacci numbers are, these are these very famous number sequences, that so it's 0, 1, 1, 2, 3, 5. So it's always a first. So the next Fibonacci number is the sum of the two previous numbers. So while we all know this kind of properties from math, but I'm interested, okay, what is a relational property among these program variables that actually ensure that what we are computing satisfy requirements of Fibonacci numbers? And it actually turns out that there is a polynomial of degree 4 among Fibonacci numbers. That's actually a specification of Fibonacci numbers being indeed Fibonacci numbers. So in principle, these are the two but mainly the two challenges that I'm addressing in my project. Okay, how can you do theory-specific reasoning together with inductive reasoning to automatically generate program properties, ensuring that your program is correct or error-free? Why you need induction? Well, you need induction because these properties that we are generating, we are mainly interested in inductive invariants, and you want to reason with them. So you have to kind of automate induction or inductive reasoning to prove that the property is indeed inductive. And why you need theory-specific reasoning? Well, we have arrays, we have integers, we have term algebras, we have such as natural numbers, lists, and you really want to bring into the axiomatizations of the well-known theories into the capability of the solver. So what actually artist-based is already on some results that already prove to make a difference. We are developing our methods using our vampire theory improver in a joint collaboration with the University of Manchester. And the focus of my work is really on generating and proving software properties that ensure that the software is error-free. And such properties are, for instance, invariants or termination functions. So just to give you a flavor, what can we do? So why do I claim that we already proved to make a difference? So for example, when we express program semantics in the first order language of standard first order language, then we could actually prove safety of 24 unique problems from the SMT-com verification challenge that could have not been proved by other SMT-based approaches such as CBC4 and Z3. And these kind of problems were mainly using from array theory, integers, and uninterpreted functions. On the other hand, recently we extended this approach to reason about security and privacy properties. And I frankly think that this work led to my ERC consolidated proposal, because in the domain of security and privacy, you really have those kind of properties where first the theory improvers are better at. They have quantifiers, they have theories, and sometimes they even have non-first order features such as aggregate functions or summation, minimum, average. So we extended our vampire-based reasoning framework to relational property verification, so basically information flow and sensitivity, And it turned out that we could prove 11 unique problems that other, again, SMT-based solvers would fail to prove. So what kind of properties are these ones? So let me just give you a very high level description of this work in terms of relational verification, and a very simplistic one as well. So assume again that you have this big piece of code, and one bit of your big piece of code, what it's doing, it's kind of updating a constant, which I call HW. And in security and privacy, this would correspond to the Hamming weight of a particular secret key. And the idea is that, very high level, that you basically count the number of ones in your key. So the Hamming weight is the sum of the number of ones in your secret key. And the secret key is stored in this array A. And now the question is this actually correct? Is it not leaking? And which can be used for a measure of side channel leakage in applications of security and privacy. And how you can address this thing, and this is how we got into this field, thanks to collaboration with Matteo Maffei from the security group at TU Wien, is that we want to show that basically if you take arbitrary copies of the same program, you want to show that whatever you're computing remains the same, no matter how you permute the array A. So there is no noise that would disturb the value of this Hamming weight function. And what does it mean? So let me just say it in very concrete cases. So what's called is kind of like K-safety or two safety properties. You take two copies of the same program, except that they are same in terms of input, let's say, except on these two cases, where there are two positions in which you just swap the two positions. Yet you want to make sure that although you did this swapping, your Hamming weight might be piecewise equal on the arrays, but the total should remain unchanged because you only swap the two elements. So what you want to show that if you sum up the array elements in red and the array elements in blue, you get the same sum. And this is what we now did for the relational verification. How can you actually prove that? And this is how, so you want to prove that the two sums correspond to the two problems are equal, despite of the swap of two elements. And if you really think how you would prove it as a mathematician, well, you would do it, okay? You will have to do an induction proof on the first portion of the two arrays, which they are equal because there was no swap. Then you make sure you use a swapping element, right? Use commutativity that makes sure that if you add up A and B or V and W, or you add up W or V, you get still the same. So you use commutativity of plus. And then you do another inductive proof on the remaining bit of the array portions. And that's exactly the problem which the most challenging problem. Theory reasoning, so commutativity of addition, for example, but it can be also other things as well. And induction, how you automate induction, which is not even a first order expressible property. So what ARTIS aims to, okay, we proved to make a difference in other frameworks, but now we want to go further and try to bring into first the theories of data structures with quantifiers, in particular focusing integer and real arithmetic, term algebras such as natural numbers, providing alternative encoding. You can represent naturals as integer numbers, which is probably the most common thing in programming, but you can also represent naturals as being a term algebra or inductively defined data type, which is more common in mathematics. You can have arrays, represent them arrays based on in the array theory with extensionality, or maybe you just need arrays as functional, so it's just function applications. The next challenge that ARTIS addresses is also automating induction, fully automating induction in first order theory improving, despite the fact that it's not a first order property. So what can we do? How can we bring inductive reasoning into first order reasoning where induction is not first order? And all this together to allow us to express program semantics, directly in the first order language of various data types, and ideally even expressing not just first order requirements, such as inductive requirements or requirements with sum. So that's what we are at, and this is what artists will start to work on and trying to make a difference, starting with 21. And if you're interested in this kind of work, you're very welcome to contact me. I'm kind of using now this platform also that if you're interested in postdoc position, please contact me. I'm looking for postdocs working on this kind of topics. So, you know, join artist. And now let me just tell you, what was my path. And this is now it's not a scientific, now I'm switching off the scientific talk of my presentation. It's mainly my personal experience that it took me to join the community and actually helped me to become a full professor at TU Vienna. So how can you actually secure your own research funds in academia? And I give you my personal view and experience on that. So, you know, probably the ideal path of becoming a faculty member after a PhD nowadays is that get a tenure track position immediately after your PhD or shortly after your PhD, which would ensure you that after some evaluation, you get a tenured position. This was a standard model already in the States, and now it's gradually quite many European universities are implementing it as well. Yet it's, you can have an alternative path. There are not so many tenure track positions as PhD students. So an alternative path could be that instead of, if you are, I'm not saying you're failing to get a tenure track position, but maybe you still lack the expertise or you still want to exploit various research topics before committing to a particular path, you just take up various postdoc positions. And then actually, I think in Europe, it's more common that you do more postdocs, but more postdoc positions before you go into a tenured position. It's quite common that from a postdoc position, you switch to a tenure track position. It's very uncommon that from a tenure track position, you go to a non-tenured postdoc position, but it can happen because of personal reasons, family reasons, other constraints. So, but in whatever you're doing, my point is that you get all these positions. Either you go for a tenure track position, either you go for the ideal path, or you go more the postdoc style tenured path. In either of the ways, you will be evaluated. You will go to all kinds of applications. You have your application will be peer reviewed at least by various people, and decisions are made whether you're going to get the positions or not. So of course, then you immediately ask, okay, why should I secure funds? Why is it important in the evaluation process? And so maybe at the very beginning, when you're finishing up your PhD and you're figuring out your career in academia, maybe in the very first step, you are not required to show up a successful grant application or success of showing that you can do your own research. But whenever it goes further, actually from non-tenured position into a tenured position, one of the criteria is that how successful have you been in acquiring research funds or securing funds. So it's all these red dots in evaluation. They will take care, or they will take into account your track record in securing research funds. So let me tell you my path. Unfortunately, I didn't have the ideal path. That time it was not even that common to do a tenure track immediately after the PhD. But I also had an unusual path in a sense that I have a double degree in math and computer science. And I did, my PhD was more in math, or actually my master's studies were more in math. And then also my PhD was in symbolic computation rather than in first the theory, proving and verification. So after I obtained my PhD from the Johannes Kepler University in Linz, I actually decided that I got very interested in program verification. And I went for a postdoc. So I applied for a postdoc position, and my first postdoc was at EPFL with Tom Hensinger. And this was like the beginning of formal methods of formal verification for me. I went for yet another postdoc at ETH Zurich in the programming methodology group with Peter Müller. And then I had another postdoc at TU Vienna, where I'm currently still am. Yet it didn't mean that I would get a tenured position. So or like after 3 postdocs, there was still no hope of getting a tenured position that time. So I applied to I actually applied to only one tenured position, tenured professorship, which was at Chalmers University of Technology in Göteborg in Sweden. And this is where I moved in 2013 as a tenured associate professor. And even ever since then, So now I'm back at TU Vienna. I had actually a double affiliation for quite many years. I was a professor both at Chalmers and TU Vienna. And in all these years, even since 2013, all kinds of steps I made in my career, they were coming with all kinds of evaluation, peer-reviewed evaluations. So how this, so you see, like I'm not in this ideal path. Never, unfortunately, didn't made it there. So it was not even possible. At least I was not aware of tenure track position at that time. I went on the most common path, which is a postdoc path, which leads to tenure position. However, during my postdoc years, I started to, so in my first postdoc, I actually used my first postdoc with Tom Hensinger at EPFL to really get myself in the field of formal verification and bringing theory improving, first the theory improving and symbolic computation into the field of program verification, analysis and verification of software systems. When I moved to my second postdoc at ETH, then I was actually very lucky, or yeah, in a sense, very lucky to get this fun experience of doing consulting with the SAW Aviation as a joint work together with ETH. So I was a postdoc at ETH working on a project with the SAW Aviation. And that started to broaden my perspective, started to give me quite much independence in terms of research idea and generate new research ideas to work upon. And the way I could come to a third postdoc to TU Vienna was actually securing my own research funding. So I applied for an individual research project from the Austrian Science Fund. It's called the Hertha Firnberg Research Funding Scheme. It's a 3-year funding scheme, and it basically was funding my own position. So I came back as a postdoc, or I came to TU Vienna as a postdoc, but I really was funding my own position from this research grant where I was a principal investigator. So my first grant where I was a principal investigator was this Hertha Firnberg research grant. And once I was at Vienna, then I started to network with people. I started to collaborate with people at TU Vienna, and there was this idea of bringing up a national research network in rigorous system engineering. That's the NFN RISE, funded by the Austrian Science Fund. So I was one of the 9 PIs. It was it's an Austrian effort, including 5 different research institutions, and I was one of the PIs of that. I also got an innovative ideas project from the TU Wien. So, but it's not like I got it; I had to apply for it. So I had to write a research proposal in both of the cases, and that proposal has been evaluated and then was successfully funded. And then I told you, so once I got my tenure position at Chalmers, it was not the end of applications and not the end of evaluations. So I'm still working or was working and still working in securing my own research funds to build up my research group. So when I went to Sweden, the year when I went to Sweden, I applied for a Swedish young investigator grant. I was successfully granted. I also became a Wallenberg Academy Fellow of the Swedish Wallenberg Foundation. And then I applied in 2014 for a starting grant from the European Research Council. And the path goes further. So in all these cases, there were all new applications with new ideas, and they have been all peer reviewed. And so I wrote this, I hope you can see the colors, but essentially I have experience in the Swedish funding schema, the Austrian funding schema, and the European research funding schema, in addition to national funding schemas as well. So you might ask, okay, why should I apply? So why should you apply and secure scientific funds as a PI? So why is it really important that you are the principal investigator? Because you can just be one of the many. Like you can do such that you're a postdoc of another principal investigator, and you're just playing along the rules that the other principal investigator is imposing. But I think that you should get your own research fund as a principal investigator because, well, for various reasons. One is that it's really critical for evaluations and promotions. So showing that it's really not that risky to trust you to give you a tenure position because you already had success in supervising maybe other students. And it's kind of also part of your scientific duties. Okay, you have to, if you are staying in academia, you have to show at one point that you are mature enough to supervise other other works as well, or to contribute to other colleagues' efforts. And of course, you can immediately say, well, it's stressful. It is indeed. It's time consuming. It is. I mean, you don't write a proposal in one day. It can take half a year to write a research proposal. Like you're digesting ideas, you're revising ideas. There are deadlines and you have to meet those deadlines. And it's also very competitive. So it's not just you applying, but it can be 3,000 other people applying for that as well. And there are only 300 places to be granted. But my take on that, that's true, but actually it's the same with any other life event, right? Everything is stressful, everything is time consuming, and everything is competitive. So just don't get discouraged if you apply and you don't get it immediately. This happens. Many effects or many factors play a role in decisions. There might be, there are other people, either they are better than you, then you can just improve on your skills. Or it might be that in that particular year, there is no funding for your research field, and then the funding has been cut. I would just say, don't get discouraged, try again. But so once you're a PI, actually, when you manage to acquire your own research funding, it brings you many benefits as well. So you overcome the stressful events, but if you're funded, and you will be eventually funded if you're good, that's my take on it, then it gives you a lot of mobility. Now, in the times of Corona, it's a bit hard to speak about experience abroad, but hopefully this will change and you can still travel and you can network with people. It will definitely give you the possibility to make your own decisions, both in terms of research, but both in terms how you want to build up your own group, which kind of people you're going to hiring, whom you can work with together. So it gives you also the possibility to shape the group the way you want to have it, instead of being only one group member of it. It will also bring you the possibility to improve your management skills, because you will have to manage, what is the funding? How many people can you hire? How can you fund all kinds of publication, dissemination activities? Are you going to organize conferences for disseminating your results, workshops, and so on? And definitely if you're a PI, or I think actually any research project, any basic research project should give you the possibility to come up with unconventional results. You write a research proposal, let's say with a time plan of 3 years. You kind of estimate what you're going to do in these 3 years, but it's very likely that you do many other things in these 3 years. That's what you prognose that you're going to do. So there will be many challenges you solve, and then you just get new challenges and new ideas, and you can do very unconventional results in that area. And altogether, actually, I do believe that when you start managing or doing your own research projects, it will broaden your research view. You will see what other people are doing in the area. You will talk to them, and you will see that maybe your solution is not as unique as you thought, or maybe it's even more unique as you thought, and you will either improve or revise. So now here's my take on this. What makes a project proposal successful and accepted? And this is really my personal view on it. And I had 2 years ago, I had a research training on more like an entrepreneurship, which was needed for my ERC proof of concept. And since then, I really think that your basic research proposal is kind of like your scientific startup. If you would go out and open your company, you have to have a unique selling point, why your company should make it. And the same is in your research proposal. If you write your research proposal and the research agency should fund it, so it's your investor, you should convince the funding agency or your investor, why is your proposal the one to be funded? What is the unique selling point that no other person can do it but you? And as such, if you're the PI of this proposal, make sure that you are really the CEO of the proposal. So, you have to convince that you can manage the proposal. You're the person, right, for doing the research, which really you're the expert of the proposal. So it's not just doing research as a PI, as I already mentioned. In my opinion, it's really a lot of management skill going on into that. So therefore, I think, when you write up your proposal, it should be new, it should be unconventional. Of course, usually the comments you get, it should not be incremental, But I have a kind of a subjective view on the non-incrementality. I think it's very risky to write a research proposal on results that you have no idea how to carry out. So if you have no credibility in the area, that to surely being, that you will write a research proposal that it's not incremental at all, but then it's too risky, right? So why will you be able to do it if you have no background in that? So I think it's good to have a bit of incrementality because of credibility, but you have to make sure that there is something really new that has not been done in your previous background or in previous research. Now, actually funding agencies, yeah, there was a question. I still cannot hear, Marco, you're muted.
Sorry. So when you start just right after your PhD, and you maybe want to apply for an ERC starting grant, it might be hard to show that you have the good experience for conducting that kind of research, or maybe you don't have yet experience of management experience of people and things like that. So what was your experience when you applied for the ERC starting grant? I saw from the list that you already had some previous experience of project before applying to the starting grant. But if you would like to suggest to a younger or former PhD student that want to apply for a ERC starting grant, what would be your suggestion?
Right. So actually, for this, I do think that depending on the funding schema, and definitely ERC starting grant is such, it's for the junior researchers. So it welcomes applications for young researchers, and the application is going to be evaluated accordingly. I think in the starting grant, it's not that important to show management skills. I'm pretty sure this is not that used in the evaluation. I didn't have myself that much management skill. I only had my own research project that funding my own position. But what is important, I think, for a starting grant, or a junior grant, is to really show that why is it you? So are you going to follow what your advisor was doing, or are you going on your path? So to show this kind of scientific independence. And now this can be tough, because if you're, depending on the PhD schema you are in, if you're in a PhD studies that you have to finish, such as in the UK, you have to finish your PhD in three years. It's really hard to do it. I think after 3 years applying for an ERC starting, then it will be hard to show credibility, unless you're really like an amazing superstar and you publish all your results alone. So therefore, I mean, for instance, also these junior research grants, they kind of say, well, show something, show some results, either a publication, a patent, or whatever, but some visible result that has been done without your PhD supervisor, or can be claimed that you are the main author of it. And I know of cases that this has worked. So very junior people, like I think 2 years or even 1 year after PhD, they got the ERC starting grant, but they had to have. So you have to make sure that this is coming through the proposal. I didn't. I applied. Actually, I applied twice to a starting grant. The first time I didn't make it, but the reason why, it was in 2012, and the reason why I didn't make it, because I actually. I will have it on the next slide. I was too risky. So I went in a research direction that I had no background in it, but I thought I can do it, and I didn't have credibility. So I had a research starting grant with 3 working packages. 2 of the work packages were really based on my experience, and the third one was really just touching upon my experience, but there was a lot of work in that area, and I didn't know that. And then, of course, then the reviewers were immediately saying, well, you're not credible. Why should you make that one? So I got my starting in 2014, right? So that was actually like 7 years after my PhD and the second application. So I think it's, that time, even for me, the ERC starting grant that time had the rule that you can only apply for a starting grant 2 years after your PhD. I think this has been changed now. Yeah. But it had a reason, right? They want to show that, they want to see that you are credible. You can work alone without depending on the guidance of other people. So my advice would be that, try to, I mean, you have to pick on something that it's yours, and you have to make that convincing, and this is yours, this is your idea, and you don't depend on the others. You can make it even if your supervisor fails to make it, you know, or you have a conflict with that.
Okay, so thanks.
And yeah, and that's surely, so what I put down, these are the general things, but I will also in the next slide. So of course you write the proposal slide. I also wrote my proposal in my starting grant proposal. I didn't have risk management. I didn't know that time what it is. I didn't know what it means, risk management. So I completely didn't have in my section, in my proposal. And now for the consolidated grant, of course it was needed to show, I learned, okay, there are all kinds of risks. You don't hire the right people. Some people quit. You don't find the right personnel. So how do you manage all this kind of risk? My impression is that or my experience is that for a starting grant, these are taken less importantly, whereas for the higher you go up on your academic career and seniority, the more important they become. So, you know, as a PI, you have to be kind of the scientific expert, but also the sales manager of your proposal. So make it sure that you have the convincing argument why it should be funded. And I think in case of artists, my argument was that there has been so much work in SMT-based verification in software development, and they have been successful. But there are so many other properties that cannot be expressed in the SMT-based verification framework. So we do need first the reasoning for that. And since I worked in first the reasoning, so that was my part that I took upon. But right, I think very importantly, because these proposals are long, they are 15 pages, 10 pages. I mean, maybe in the best case, 5 pages, then you have to write a bit less. But they are long, and the reviewers, they have to read quite many proposals. I'm also reviewing things, and I see that there's so many things to read, and you have a very limited time schedule. So I think what is very important when you write up your proposal, that everyone has to read the abstract and the introduction. But you really have to catch the attention of the reviewer that there is this message at the very beginning of your proposal. Why is your proposal unique? And then you raise the attention so that she reads further your proposal. And so therefore, I think, the overall story, there should be a bit of motivation. Why is this problem important? But it should come very soon across what kind of problem the proposal is addressing. Most importantly, even it's a basic research funding. I mean, I'm mainly working in basic research. It should be still clear what is the potential impact. So why should it be important for the society? And that should be, you should make your important messages unmissable. You can put it around in some graphical boxes, but make it clear that this is something that has to be read, and it has to come at the very first page of the introduction. That's my point. Now, you read in the evaluations that there will be expert reviewers reviewing your proposal. That's true, but you have to be sure that you are still the expert of your proposal. So other experts are reviewing your proposal, but you are still the expert writing the proposal. So it cannot be that you write something, let's say on, I don't know, you do something on theory reasoning and you are not the expert. And of course the reviewer can already tell you, I can do this better, or there are other people doing it better. So while they are the expert reviewers as reviewers of your proposal, but you are the expert PI of your proposal. And yeah, try to make a scientific language that is accessible. So especially in my area, I mean, I'm also a logician, mathematician, so it's very hard to get in, very easy to get lost in formalism. I can write a lot of Greek letters and a lot of Greek formulas, and I'm not sure all the reviewers or the expert reviewers will appreciate it. So it's better to get it more either natural language or some examples surely help, but try to find a balance there. And then what I learned actually after my failing ERC starting grant, so it was in 2012, and then I reapplied in 2014. Maybe it helped, I don't know, but I learned that lesson. So everyone has to submit a CV or a track record of your, what have you achieved so far, even if you're the more junior person. So of course you can make a bullet list there, and that's perfectly fine. And this is what I also have done. Like, the bullet list, I didn't have much experience, so I just done it. I actually think it's much better if you, so, you can say that you had, I don't know, I had a Festo prize, and I only wrote it down as a bullet list. I'm sure the reviewer, when it read, it was okay. She had a prize, but the reviewer didn't know what a Festo prize is. So it would be just much better if you just put 1 or 2 sentences saying that this prize is from the Austrian telecom company supporting young talents in that area. So it sounds completely different. It explains what this prize is about. So I think actually it's very good, and this is what I've done since then, since 2014, when I write my track record. Usually you get about 2 pages to write this up. I have a bit of bullet list, but I also have 1 paragraph starting with the most important achievements of my track record and explaining what these achievements mean. And finally, like, I think never underestimate the non-scientific sections, such as dissemination of results. So how are you going to disseminate your results? What kind of outreach activities you would have, and what kind of risk analysis? How you manage the project if there are risks. As I said, I didn't have these things in my starting grant. Probably it's when you're more junior, this will not count as much. But I think actually the more funding you get, the more important the scientific section, non-scientific sections are, because you get more money. So what is the risk of not spending the money? What is the risk that you don't succeed with all the goals that you are going to, you are proposing to achieve? I think it's good to provide the reviewer to accept your proposal, like give arguments. You can write. So I think one strategy could be that you can really openly say, that my research agenda that I'm proposing now might have not been possible 3 years ago. And then highlight the main reasons why you think that actually now it is possible. So then the reviewer can write this up in the report. So she can just look it up. Is it the case? If it is, she will write it up in the report that indeed this is the case, that these are the unique selling point of your proposal. And what I learned from my failing ERC starting grant proposal is be fair, but critical with related work. So I missed pretty much, I didn't have the experience that time either. So I really missed almost completely 1 research field in computer science. And I wrote up a research proposal, 1 work package on that research field without citing very seminal related works. And there, of course, you get a reviewer from that research field, and that reviewer will know the field and then immediately points out to the right related work. And I have no credibility of convincing that I can actually do it. So, that's actually my personal view and experience on that. And I think it's very individual. These are my lessons that I learned, and I would just say, join artists if you're interested. Very welcome to contact me. Join the community. If you get a failing proposal, don't get disappointed. It's like you have a publication that is not accepted, and you resubmit, you revise and resubmit. So try to learn from the failures and resubmit. I also resubmitted. It was not that I got all the time 100% success rate. Yeah, so that's my presentation. If you have questions, feel free to ask.
Yeah. So are there questions? So there is a question on the chat.
Yeah, I see it. How is the fund usage is controlled by investors? So I think it's very different which kind of funding you are. Okay, so now my investors are the basic research funding agencies, and each funding agency has different kind of control. Some, let's say the Austrian Science Fund and also the Swedish Science Fund, and I think probably most national science fund would require that you submit yearly reports on the progress that has been made in terms of scientific progress. So what goals have been achieved. It's completely fine to also report on changes in the research plan, but you have to, of course, explain. And usually the research agencies are accepting changes quite liberally if you make sure that those changes are valid and valuable. And in addition to that, you also have to usually provide a financial report. Okay, how much has been spent so far? Are you overspending? Are you underspending? If you're overspending, what is your plan for the upcoming years? And if you're underspending, how will you use the additional funds, the surplus? And actually, underspending has been now a common thing in the past year for many people because of the Corona crisis. Especially in computer science, you travel a lot, you disseminate, you network. Now you couldn't travel. So also in my research reports, I had to explain how I envision the understanding in terms of non-traveling. ERC, for example, requires midterm reports. So it's I only had to, so it's 4 reports in 5 years. The first report is it's kind of just a financial report and very brief description of your scientific results. And the midterm report, which is after 2.5 years, that's where the scientific report is more important. So you should express or should explain what have you achieved, what publications you made, how many of them, are there software releases in my cases, dissemination, project results, conferences that we organized. So this is how they control it. I never got yet in the experience in either of the control activities. So all my reports have been so far accepted, and I hope it's going to be like that. But it can be that if the the report is not accepted, then basically the funding is cut or adjusted. Right, so
I have a question.
Yeah, sure.
Hi. Thank you for the interesting talk. Going back to the technical part, I see that you focus more on inductive properties. Can you comment about the capability of so I guess that these inductive properties are quite close to the actual program. So can you comment about the capability of finding bugs in the software based on this, compared, for example, to techniques tailored to property verification, where you first specify what the program should do?
Right, so we can do actually 2 ways. We can do this kind of property-driven verification that would, in some cases, can ease the finding the inductive property that is strong enough to prove the property that was given. But but we do it differently in a sense that we are not restricted to the given property signature language. So since we are doing this kind of consequence finding approach in first the theory improving, that's different with respect to SMT solvers. So SMT solvers, they are restricted. So the problem language for SMT solvers would be given by the symbols from your input property. Now, in case of consequence finding in first theory improving, we start with this initial vocabulary, but we can actually generate new and new symbols as well. This is how actually alternations of so we are eliminating predicate and function symbols by introducing additional variables. And that's especially for the quantified inductive property. This is something that is important because it might be that so it's really like how mathematician would prove, right? Sometimes you prove an inductive property by generalizing it. You prove something stronger. So you're not restricted to the input property. You go one step ahead. You prove that something is a stronger property, and then as a consequence, you get your given property. So we have also this approach of which is called, for instance, induction with generalization, where basically we replace, let's say, think of x plus x, and instead of working with x plus x, I just introduce a variable y that stands for x plus x, and I prove over y instead of having x plus x. So I kind of hide some terms in some additional variable or term, and that's yeah. So definitely but we have this induction with generalization that allows us to prove other properties. Yeah, that's a good one. I think the second one from Alessandro. Where is the border, if any, between submitting something really meaningful rather than something just to obtain funds and survive? I don't know that border, seriously. So, I mean, I have been lucky since 2014. But when I moved to Sweden, so okay, so I think it's really depending on what kind of position you have. When I took up my tenure position in Sweden, I get this 1-year generous funding, startup funding, which kind of allowed me not to work in this survival modus, because at least I could finance for 1 year my group, and I even get 1 PhD position. So I could actually take some time and think, because I had an ERC proposal that has failed. So I had some time to rethink, okay, what are actually the priorities I want to work on, and wrote up the proposal accordingly. So I didn't want this in survival modus, but I can completely understand if you're in the survival modus and you have to fund your group, then sometimes you make compromises. Then sometimes you write, I mean, you agree on short-term projects, or I don't think there is a well-defined border for that. I think if you have the privilege, and I had the privilege in 2013 to spend 6 months on identifying what I want to do, how I want to improve my failing ERC proposal, then that helped. Right, so when my project got rejected, was actually in that case was, so I had very good experience, even in the terms of negative things. I had a very good experience from here. It was very clear why my project was expected. It was really why it was rejected, sorry. So it was very clear that this was, yeah, so I told you, I touched upon a research agenda that has been done by others. That was also a mistake on my side, because maybe that's coming back to the previous question. When I wrote my first ERC proposal, it was in 2012. I had no perspective of a tenured position. The only tenured position I could think of was getting an ERC starting grant. So I was kind of in the survival modus. Let's write a research proposal in 3 months. And I didn't have the time to discuss all my ideas. I'm sure if I would have discussed more with my colleagues, even with my senior colleagues, they would have alerted me that this thing, it was program understanding. This thing has been done by other researchers, so look it up. I didn't have the time. I had to meet the deadline. Yeah, so that was a bit unfortunate, and it also yielded a rejection. But the rejection made it clear why it was rejected. So it was saying, no, it's not credible. It's unclear that you can make it on that. They both commented that on other parts, I'm credible, I'm the expert, but they were really saying it's not the case. And I had one more in Vienna, one more research proposal rejected 2 years ago. That's my second, and there I think again it was a feedback good. We were too high level, and that's again I have a question: where are you? Are you too high level without giving concrete examples, or are you more entering the concrete examples but then you're too specific? So we get in too many details on the technology just because you were hiding details.
Are there more questions?
Yeah, I can send you the slides. It's yeah, I have some, because of these pictures, I have a bit of, if you're fine with 18 megabytes, I can send Marco I can put up somewhere on my webpage and send you the link, and I'm completely fine.
Sure. I mean, you can send it either to me or to the secretary of the doctoral school, and then they will circulate it to the participants.
Yeah. Maybe just one more thing, which I forgot to say, but now from the discussion, I think what is I didn't put it on the slide, but I think what golden rule is: try to discuss your proposal with people. I mean, give what it's about, get feedback on that. But ultimately, don't make changes in your proposal that you don't believe in that, because if you're invited for an interview, this will show up. So, you know, if people tell you that work on, I don't know, trigger-based instantiation, and I don't believe in that, then they will, in the interview, it will come out later that I don't believe in that. So discuss, but make it sure that it's still your proposal.
So I have a last question. So you have been awarded for the 3 ERC grants, so junior, intermediate, and consolidator. Do you think that you have always to follow this path, or you can enter in any of the, let's say, the levels of grants?
I think you can enter at any level. ERC, at least my experience. So for the proof, so I have a starting grant and the proof of concept. Now for the proof of concept grant, you have to have an ERC grant, because this proof of concept is built upon of the ideas of commercializing or investigating social impact of an existing ERC idea already. So the grant is very different in the sense that they don't evaluate their scientific excellence. It's more like the impact of a scientific excellent idea, kind of. But I think it has both benefits and also negative things, because if you're going from an ERC, and this is what I heard, if you go from an ERC starting grant to an ERC consolidated grant, then you really have to make the story convincing that it's just not a continuation of the starting grant. Okay, so this will not be funded. So it has to have something unique. So therefore, I think if you just jump in at any funding level, you will not have that kind of comments. People will be, in this respect, a bit less critical. They will not look up, okay, what are the results of this ERC starting grant? Has there been anything done there that can actually make credible that the consolidated grant is a good investment? So I think it's not that easy, but it's, of course, it gets a bit of benefit. When you have a starting grant, people will at least pay more attention, I think, when they read your CV.